A statistician's wife had twins. He was delighted. He rang the minister, who was also delighted. Bring them to church on Sunday and we'll baptize them, said the minister. No, replied the statistician. Baptize one. We'll keep the other as a control. Do you get it? Experiments, etc. So let's go ahead and talk about how to do random assignment on an experiment and get it right on the AP test. A key principle of random assignment for experiments is that all subjects must have an equal opportunity to be assigned to any of the treatment groups. So how do we do random assignment? Well, first of all, I'm going to show you this example where they're examining two curriculums, well, the normal plus something called Career Start. And this is one experimental design. Now, on the AP test, don't just draw a diagram. You have to explain how the treatments are assigned and what will be measured and compared. So it may seem like you're kind of showing it here, but you have to provide more detail. So describe how you would randomly assign 14 middle schools to each of the two methods. And we're going to talk about the hat method, using technology, and using a random number table. So, but before I do that, let's talk about this experiment. What are the experimental units? The middle schools. The factor is Career Start. We think that's going to create a difference. The explanatory variable is the curriculum type. Very often these two are very much related, the factor and the explanatory variable. The treatments, well, we're going to get normal curriculum or normal curriculum and Career Start, so that would be the levels. And the response variables are all these. We're going to compare attendance, behavior, test scores, engagement, and graduation rates. So if I was going to assign the 14 middle schools using the hat method, which is always the simplest, the gold standard, well, write each name, subject's name on one of the slips, in this case, one of the school names. Put all the slips in the hat and mix thoroughly. Draw them out one at a time until you have 7 slips. Everyone had a shot at being in the first group, and that's good. So those 7 slips will get the treatment of the normal curriculum and Career Start, and the remaining will just get the normal curriculum. An alternative, which works fine as well, is write Career Start on 7 slips and regular curriculum on 7 slips. Put them in a hat, mix it thoroughly, have the subjects come up one by one, and pick up a slip from the hat. This guarantees that 7 schools per group with the treatments are assigned by chance. And as you recall, we looked at that 2018 AP question, or actually 2017 free response question, where they did the chip method and the flipping the coin method. And this is a lot like the chip method in that example. So using technology, give numbers 1 to 14 to the schools in alphabetical order. And then we use a random integer function, which is under math, PRV, and generate random numbers. So you can say, give me random numbers from 1 through 14. Make sure to ignore any repeated numbers. It's not like a school's going to participate twice. And once the first 7 different numbers are chosen, those are the ones in the first treatment group. And the second group, the rest go in the second treatment group. Finally, a random number table. With this one, it's a little difficult because if I do 1 through 14 and use 2 digits, it's going to take a while. So what I'm going to do is actually divide the digits from 0 to 99 among the 14 schools equally. A little unorthodox, but it'll work. So I'm going to say 0, 0 to 06 is school 1. And I'm going to go in groups of 7 all the way until I get to school 14, which will be getting up to 97. And ignore 98 and 99 because I don't want any school to have a more than equal chance than the others. I'm going to use a line on the random number table, select 2-digit numbers for each school, ignoring repeats till you have selected 7 unique schools for the treatment. So here's my random number line. And so I'm going to read it in 2-digit groups, moving from left to right. So the first 14 labels identify the 17 schools assigned to treatment 1. Actually, it should be first 7. All right. So this first group, that would be group 3. So if I go 00 to 06, then 07 to 013, this would be in the 3rd group. This one would be in the 6th group, and this one would be in the 13th group. So far I have 3 different schools, school 3, school 6, school 13. Then 18 I'm not going to use because that's actually in group 3, and I already pulled that one. 99 is one of my ignores. 04 is group 1. 15 would be in group 3 again. 35 would be in group 6. 33 would be in group 5. 81 is in group 12. 79 is also in group 12. 40, we already pulled 40. 12 is in group 2, which means I'm, let's see, I'm almost there. I've got 1, 2, 3, 4, 5, 6. 14 is in group 3, believe it or not. 38, I've already used. 83, nope, that's group 1. 59 is group 9. So the schools I would choose are schools 1, 3, 6, 1, 2, 3, 6, 1, 2, 3, 5, 6, 9, 12, and 13 if I'm trying to go in order. So it's a little more difficult using the random number table rather than, say, technology or the simplest, which is the hat method. So what if I just flip a coin? And I'm going to go ahead and go over this again. We sort of covered this. We did cover this with the 2017 free response question number 6. But a lot of times people think, if you just flip a coin as you go through, that would be fine. And it is, as long as all subjects toss a coin and it's still completely randomized design. If you're only tossing until you fill the group, that's where the problem comes in. All right. So usually we want the groups to be equal. So what happens if we force the groups to be equal? We keep flipping until one of the treatments is filled. Once it's filled, then every other subject on the list is forced into the other group. They are no longer assigned by chance. And the last subjects on the list will almost always be assigned to the unfilled group, leading to a bias. What if we had the schools listed by the time they signed up, when the first schools be when the first schools be a little more enthusiastic? So that might be a source of bias. So this is a problem. We should not force the groups to be equal. We should use one of the other methods. But just in case you didn't get it, and this was for my prior year when I didn't cover that example, we have Amy, Bettina, Carl, and David, and we want to put them in 2 groups, and we're going to have them flip heads or tails. Heads is group A, tails is group B. So the probability of heads and heads is 1/4. Tails and tails is 1/4. Heads, tails, heads is 1/8. So I'm just flipping until I have a group filled. And we kind of worked through that on our example. So the probability that Amy and Bettina are in group A by flipping a coin is 1/4. Now there are 6 possible different outcomes, but 16 ways to flip the coins. We're basically ignoring 10 invalid outcomes because our groups would be filled. So you can see here, these are the outcomes that fit that. Well, there are 6 different groups, so the probability should be 1/6 for each. The hat method will work, but the coin flipping method will not. Now, last but not least on this part of the notes, I did an experiment to compare automated grading to grading by hand for classwork and to see if it could improve my students' mastery. So how could we create a completely randomized design? Well, I would take my students' names, put them in a hat, split them between group 1 and group 2. So I would draw students until group 1 is filled and the rest go to group 2. And I do automated grading on group 1, regular grading on group 2, and use their DCA scores as a response variable. So this was for my geometry group that I compared scores on.